Okay, so today we're going to be talking about types of bonds. So the first type of bond is ionic bonds. So that is an electrostatic attraction between metals and ions. So it's usually a metal, electrostatic attraction between ions. Sorry, I misspoke. And it's usually between a metal and a nonmetal. So they're very strong bonds because the ions are close together because there's an electron transfer, and they have really high melting points because they're usually solids with a crystal lattice structure, and they're also really good conductors when they're dissolved because there are freely floating ions. So as you can see, this is a Lewis dot structure right here of NaCl. This is how you do a Lewis dot of an ionic bond. You have to put these brackets with the charge, but this just helps better sort of describe and show you what an ionic bond actually looks like. Okay, so next we're going to talk about covalent bonds. So those are when the electrons are shared by nuclei. And in this example of F2, it's not going to apply here. But if you had a different example, let's say if you had water, so H2O, the more electronegative element will attract the shared electrons strongly. So in H2O, the oxygen molecule is going to be really strongly pulling the electrons toward it. So that's why that's a polar substance because of the electronegative oxygen pulling the electrons toward it. But we're going to talk more about that in another video. Covalent bonds, so those substances may exist in any state. They are non-conductive of electricity, and they melt at low temperatures. Okay, and then metallic bonds are bonds between metals. They usually have a lattice structure. They have delocalized electrons, so the electrons float freely around the lattice structure. So as you can see here, the electrons are just sort of sitting there, and they can sort of float around wherever they want. And there's a range of melting points for these, and they are really good conductors of electricity because the delocalized electrons are free to move and conduct electricity. Next, we're going to talk about bond energy, which is the energy required to break a bond. So these can be used, we'll talk about more of this, and we'll probably do a problem on this, but this is just a bond energy table right here. And using these bond energies, you can actually add them all up in a chemical reaction, and then do products minus reactants. If you multiply and add all of these, so you have the products and reactants, and you can find delta H. So that's just a helpful thing that we can do with bond energy. And then bond length is the distance between the two nuclei where their energy is at a minimum. So that's key, the energy at a minimum. So we know that we always want to have a low energy state because that's where things like to be. So if you look at this graph right here, you can see that this is number 3 position. That is the actual bond length, and that's where it is because that's the lowest energy. So it wants to have the lowest energy. So that's why it has this. That's why it has that bond length. That's all. Thank you.